All right, guys, let's get it going. Let's go ahead and do number one. Okay, number one, it says you are going to multiply this out to check if this is the factored form of this problem. So in essence, this is our answer after we multiply. We want to check if this was actually the real problem, okay, the factored form. The reason this is called the factored form is because it's all multiplication. 2 times x plus 6 times x minus 5. If you recall from previous weeks, these are all called factors. So I have 3 factors here, and that's why it's called factored form. So to check, in this case, we're just going to multiply this out and see if it matches our original problem. All right. So what I like to do first is I'm going to ignore basically the number in front, and I'm going to do multiplication of this. So I'm going to go x times x. X times x gives me x squared. Then I'm going to go x times negative 5. That gives me negative 5x. Okay, we're done with the x. Now I'm going to do the same for the second term in our first parentheses. So it's going to go 6 times x now. That gives me positive 6x. And 6 times negative 5, that gives me negative 30. Okay, all in parentheses. I still have the 2 in front. Before I multiply this in, I'm going to combine these like terms here. So CLT. So I'm going to have x squared, negative 5x and positive 6 is positive x, or 1x, minus 30. And now we have 2 out in front, and then I'm going to distribute it in. That gives me 2x squared plus 2x minus 60. Now I just got to check, does it match what I have here? If it matches, then you would say, yes, it is the factored form. So again, this is in factored form of this problem. Okay, let's jump over to number 2, same idea. We're checking, is this the factored form of this? So we're going to multiply this out. So this power of 2 means I have to multiply this twice. Not multiply by 2, but multiply itself twice. So it looks like this. You have 3x on the outside, x plus 4 once, and then because of the power of 2, we're going to multiply x plus 4 twice. All right, and we're going to do the same process. X times x, x squared. X times 4, positive 4x. Done with the x's. 4 times x is positive 4x. 4 times 4 is positive 16. Bring down the 3x. We're going to combine like terms here. 4x and 4x is 8x. So it's x squared plus 8x. Notice when I combine like terms, I'm not doing anything to the exponent. So it's just x and x. When I add or subtract, just stays x. It doesn't say x squared, okay? It stays x when you're adding and subtracting. Bring down the 3x, and we're going to multiply in the 3x. So 3x times x squared. So when we did this before, it's getting really 3 times, and then the number here is 1. So 3 times 1 is 3. And then x times x squared. When you multiply variables, you add the exponents. So there's a power of 1 here. So we have 1x, and we're multiplying with 2 more x's. That gives me a total of 3 x's. Okay, x to the power of 3. Now we're going to do the same thing here. 3 times 8 is positive 24. X times x, how many total x's do we have? We add them. That's going to be x to the second. Okay, 3 times 16. If you need a calculator, grab it. 3 times 16, that gives us 48. And then x times no x is just one single x here. And then just check, do I combine any of these like terms? And the answer is no. Does it match what I'm supposed to have up here? And then it's no, not a factor. Okay, so 3 and 4 I'll let you do on your own. We are going to jump to the next section of problems. Okay, so this is factoring here. So if you think about it, what these next section of problems, they have given us this. We got to turn it back into factored form. That's what it's asking. They gave us the answer. We now have to turn it back into factored form. If you recall, you have some weapons that I talked about last week. The first weapon you always want to look for is GCF. Can I divide something, number or variable, all the way throughout the entire problem? Okay. This other weapons that we have. So GCF, I put it in its own category because when do you use GCF? You always want to try it. So every problem, you start off with GCF if you can do it. Okay. After you do GCF, then you have to make a decision. Do I have X or diamond method, or am I using snowflake method? And this is all dependent on the A value. Is the A value equal to 1, or is the A value not equal to 1? Okay, so remember, both of these, X method and snowflake method, yes, you got to look at the A value, but they better have the quadratic pattern. So this is something we talked about last week. Okay, so quadratic pattern, that's when you have a power of 2, a power of 1, and then a constant. All right, you'll see it in a little bit as we go through this. You should be pretty good with what a quadratic pattern has. It has an A, B, and C value. All right, let's look at number 5. Okay, so GCF. I want to check out, do I have a GCF? So let's look at the numbers in each term. Remember, we have this term, that's one term, second term, third term. Okay, so what we want to figure out, looking at the numbers in each term, ignore the variables for now, looking at the numbers for each term, can they be divided by the same number? Okay, so this is how I would do it. Out of all three of these numbers, which one is the smallest number? And that answer is 4. So I want to figure out what's the only things that can divide 4. So I know 1, 2, and 4 are the only three numbers that can divide 4. So what I'm going to do is, of my list, because I want the greatest number, the biggest number, I'm going to check the biggest number on the list I just created. So I'm going to check, does 4 divide 4? Well, we know it does because that's how we got our list. So we know 4 can divide this 4. Then I'm going to just take my calculator and say 20 divided by 4. Do I get a good number? Do I get an answer that's not decimal? And the answer is yes. 20 can be divided by 4. Now I'm going to go to 144 and check, can 144 be divided by 4? And if you throw that in your calculator, you do get an answer. Okay? So that means the greatest common factor I have so far is 4. So I'm going to just write my GCF here. Okay, so I figured out the GCF for the number, but now we got to check out the variables. I have a variable x, no variable. They all have to have the same exact letter for each. Okay, ignoring the power, you just want the letter. The problem is this last guy does not have an x, therefore there is no variable GCF. So my GCF, the only thing that can divide all three terms here is 4. So we're going to complete the GCF process. So the next step in GCF, is dividing by 4. Okay, so now let's divide by 4. 4 divided by 4 is 1. And then we just bring down the x squared because there's nothing to divide the x squared. Negative 20 divided by 4 is negative 5. Bring down the x. Okay, negative 144 divided by 4. If you throw this in your calculator, it's negative 36. Okay, this all goes in parentheses, and our GCF gets multiplied in front. All right, so we've used GCF, but just because this is the section we're doing now, just because GCF worked does not mean we're done. We now have to look at the factors we have left over. So we got 2 factors. We got a factor of 4 and a factor of x squared minus 5x minus 36. This is an entire factor. So looking at these factors, can I use one of these methods on the factor? Hopefully it's obvious that 4 cannot factor anymore. We're done with the 4 in front. But the stuff inside, we got to check, is it the quadratic pattern? And if you notice, the quadratic pattern says you better have a power of 2. Then the next term better have a power of 1, or x to the first power, which it does. And then the last term is your constant, no power at all. That is called the quadratic pattern, which we also call the A, B, C pattern. Okay? The numbers in each one of these terms is your A value. So my A value is 1, my B value is negative 5, and my C value is negative 36. So because it has a quadratic pattern, I know one of these methods might work. So I got to decide which one it is. Which tool or weapon am I going to use to fix this problem? And here's the hint. Look at your A value. Is it equal to 1? And the answer is yes. Therefore, I'm using diamond method. Okay? Again, it may or may not work, but we got to try it, because our goal is to factor as much as we can. So if you recall, diamond method is 8 times C on top. 1 times negative 36, that's negative 36. Okay, and then our B value goes on the bottom. That's negative 5. Okay, and now I'm asking myself, what can multiply to negative 36 and also add up to negative 5? So I'm looking for the magic pair here. And if you're good at math, it's pretty simple. It's going to be negative 9 times positive 4. So let's check it. Negative 9 times 4, negative 36. Negative 9 plus 4, negative 5. This is my magic pair. When you're doing the X method, we're going to take our magic pair and put it into our template. Okay? So the way we complete the template, we take our X variable. Our first one here is X to the second. Since there's 2 X's, each one of these get an X. Okay, and then we just put in our magic pair numbers with their signs. So negative 9 is going to go here. And then positive 4 is going to go in here. And don't forget that we had a GCF. We got to put all the factors in our final answer. Okay. This is factored form. All right. So basically we have factored. All right. In this particular problem, they want us to check your answer. How do I check my answer? We do what we did for number 1 and 2. We're going to multiply our factor form out to see if I get our original. So let's try it for number 5. So I'm going to multiply this out, okay, to see if I get my original problem back. And if we do, that means we did it correctly. So this is the checking your answer phase. So I'm going to take these two guys and multiply them. X times X, okay? So remember, when you multiply variables, X times X, ask yourselves, how many total variables do you have when you're multiplying? So I got X1 here, okay? X1 here, X to the first power here. So think of it this way, X to the first, X to the first. When I multiply that together, it really is X to the second. I got two of them. This only works when you're multiplying, okay? X times 4, so that's going to give me positive 4, and I only have one X. And then we are done with this, okay? So now we're going to go negative 9 times 1x. That gives me negative 9x. Negative 9 times 4, that gives me negative 36. Combine these like terms, we get x squared minus 5x minus 36. And don't forget, we have to multiply in our GCF. So 4 times x squared, that's just going to give me 4x squared. 4 times negative 5, that's negative 20x. And 4 times negative 36, negative 144. So if you look, we should get our original problem back if we did everything correctly. And so we do. That means we factored correctly. Okay? So that's how you would check your answer. All right, let's jump over to number 6. So number 6, GCF, let's check. Let's check the numbers. We have the number 1 in front, and we have negative 4. So I'm going to list everything that multiply or divides the smallest number. And the only thing that can divide the smallest number is 1. Okay? We know 1 can divide 4, but when we have a GCF, we can't use 1 as our GCF. So that means we do not actually have a number GCF. Okay? So 1 cannot be used as our GCF. So we know number GCF doesn't work, but we got to then check, do I have a variable GCF? How do I check for variable? In this case, we have two terms. Okay? Do they both have the same letter? And the answer is yes. They have M and M. So that means my GCF better have the letter in it as well. Okay? So now I got to figure out what power should I put in my GCF. So you look at, we have M to the power of 3 and M to the power of 1. The rule I've mentioned before is you pick the lower powered exponent. That's your GCF. So it's going to be M to the 1. Okay? So we don't really need the 1 there, but I just wanted to point that out. So now once we have our GCF, we divide by our GCF, which is, in this case, is just the variable M. So we have M to the third. I'm dividing one M away. So in essence, when I do that math, it gives me M to the second. Okay? Now we have negative 4M divided by M. So negative 4 does not get divided by anything. So we're just going to go minus 4. And then we have M to the first, and we're dividing away an M to the first. So what happens here is these cancel out. So we're left with M squared minus 4, and we turn it into factored form by putting our GCF in front. Okay? Remember, just because we did GCF doesn't mean we're done. We got to check, can one of these other methods work for my factors here? Okay? So if you look here in my factors, we see that it does have the quadratic pattern. We have a power of 2 here. Okay? So that means we should check for the quadratic pattern here. So how do I check for the quadratic pattern? We have to understand that the power of 2 is always, that's what makes it quadratic, because it has a power of 2. The power of 2, guys, always your A value. Okay? The guy without the variable, give me a second, guys. All right, the guy without the variable, this guy, he's your C value. And the value that we're missing in the middle is our B value. We're actually missing him. So what that means is it is the ABC pattern. Okay, just like we have here, A, B, C. The only problem now is our B is 0. Okay, so in other words, I can rewrite this guy so that it's the quadratic pattern, the ABC pattern. So we have M squared, that's our A, plus 0B. When you're missing one of these guys, it's a 0. Sorry, 0M. That's my B value. And then minus 4 is our C value. Okay? So I know it did not look like our ABC pattern to begin with, but if you have a power of 2, it's probably one of these methods. We have to then put in our B value if it's missing. And we use a 0 for our B value. Okay? Now you look, it's the ABC pattern. Now we got to check which one is my A value. If you look in front, the number in front of my M squared, which is our A value, is actually 1. So this is going to be the diamond method again. Okay, so we're going to go A times C. That's negative 4 on top. And then B value is 0. Okay, and now we're going to figure out the magic pair. What multiplies a negative 4? That adds up to 0. That's simple. Negative 2, positive 2. Once we have our magic pair, we put it into our parentheses, the factors form. Split our variable here. We have 2 of them, so we're going to split them evenly into each factor. So that's M here, M here. Negative 2 goes in this guy, positive 2 goes in this guy, and we bring down our GCF of M. This is factor form. Okay? I'm not going to check it for you. You can do that by multiplying this back out. Okay? All right. So I'll let you try 7 and 8. 7 is very similar to this guy. Notice we're missing the middle guy. We only have 2 of them. So GCF, check for ABC or quadratic pattern. If you're missing the B value, put it in. All right? Again, if you need extra help, come in, stay after class or come into office hours, okay? So let's go one more section over. Okay, let's do number 9 and we'll call it a day. So number 9. Again, we're going to look for GCF first. So out of all of these, I'm going to pick the smallest number. So if you look, the smallest number I have out of 12, 27, and 27 is 12. So I'm now going to list all the numbers that multiply to 12. So there's actually quite a few. 1, 2, 3, 4, 6, 12. All right, so these are all the numbers I know definitely will divide 12. What I have to figure out is which one of these is the biggest number that will divide these 2 numbers. Okay, so I like to start on the biggest number in my list. Can 12 also divide 27? And the answer is no. So 12 is not my GCF. Can 6 divide 27? Again, simply just use your calculator. 27 divided by 6, check if it works. And the answer is 6 doesn't work. So now I go to the next biggest number. Can 4 divide 27? Okay, and the answer is no. So now I'm down to 3. Can 3 divide 27? And that answer is yes. So 3 is my greatest common factor. So my GCF is 3 because it's the biggest number that can divide 12, 27, and 27. Now let's check for variable. Do they all have the same variable? And the answer is no. Okay, therefore there is no variable in our GCF. Let's go ahead and take our GCF and divide it away. Now let's do it. 12 divided by 3 is 4. And we bring down the t squared. Negative 27 divided by 3 is actually negative 9. Bring down the t. And the same thing here. Negative 27 divided by 3 is negative 9. Bring down nothing. There's no variable there. So that goes in parentheses. And we put our GCF multiplying in front. We're not done. We got to check our factors. Can this still be factored using diamond or snowflake? So remember, this guy and this guy, these guys are the quadratic pattern. This works when you have a quadratic pattern and the a value is 1. This works when you have a quadratic pattern and the a value is not 1. Okay? So let's look at this factor here. We have a power of 2. That's the quadratic. Now we check the pattern. Power of 2. That means this guy's my a value. A single variable to the power of 1. That means this guy's my b value. And the guy without the variable is always my c value. So if you look, I have the quadratic pattern. And because my a value is 4, I'm using snowflake method. So let's go ahead and do snowflake method. And this is something we covered last week, but maybe you forgot. So it's a times c on top. That's 4 times negative 9. That's negative 36. Our b value is negative 9 on bottom. Okay. In this section here, we put our a value. So 4. And the same for the other side. 4. And then we split our variable. Instead of t squared, it's just t and t. And now to fill in these blanks, we ask ourselves, what multiplies to negative 36? That can also add up to 9. Okay? So think about that real quick. So if you're good with this, you should have negative 12 and positive 3. Okay, so again, just got to be comfortable. It might take you a while, but use your calculator. See what multiplies to 36. So negative 12 times 3, negative 36. Negative 12 plus 3, negative 9. So I have found my magic pair. But when we're doing snowflake, we have an extra step here. We're going to look at this and notice it's set up like a fraction. Can I reduce this? So we have to go back to elementary school and reducing fractions. What's the biggest number that can divide both of these numbers? So if you think about it, it's 4. I can reduce by 4. Okay, 4 divided by 4, that turns into 1t. Negative 12 divided by 4, that turns into 3, or negative 3. Same thing on the other side. Can I reduce this? And the answer is no. It stays the same. So now we put it into our factored form. So 2 parentheses. 1t minus 3 goes in the first one, or t minus 3. And the next one is 4t minus 3. Just kind of drop them in. 4t minus 3. And don't forget, if you had a GCF, that's a factor. It has to go in front. So my GCF was 3. That has to go multiplied in front. All right, guys, that's factored form. Okay, if you want, check your answer by multiplying this out. All right, I'm going to get you the check-in code and get you out of here. If you have questions, stay on and I will help you out.